Hello, everyone. Ooh, the screen's way off. Hello, everyone, and welcome back. Where we've been tackling FRQs in preparation for this year's AP exam, specifically looking at those that involve, array lists, arrays, classes, methods, that sort of thing. We know that there's only going to be the first 7 chapters, as they call it, first 7 units. Sorry, this go around, and not all 10 units. So with that in mind, let's take a look at today's FRQ. This is coming from 2012, number 1. I've assigned this one in my classes in the past. I can't remember if I did it this year or not. We're just going to go ahead and knock it out. So, a mountain climbing club maintains a record of climbs that its members have made. Information about a climb includes the name of the mountain peak and the amount of time it took to reach the top. The information is contained in the climb info class declared below. So we see we got a constructor which takes in the name of the peak and the amount of time using an integer. This is something I would specify. Okay, this is in minutes. Okay. Then we have just a getter for that and a getter for our time. So we're going to have to make this class, but they basically provide it to us in the FRQ. The climbing club class maintains a list, right? This is back when they were using a lot of list. You could just use array list here. List is an interface, and an array list is a list. It is beneath it in a class hierarchy. But the only list we happen to know is array list. There are more. If we were just to say array list here, for all intents and purposes, it's the exact same thing. So this class maintains a list of the climbs made by members of the club. The declaration of the climbing club class is shown below. You will write 2 different implementations of the add climb method. You will also answer 2 questions about an implementation of the distance peak names method. Interesting. So we have this instance variable. We then have the climbing club constructor, which is just completed. It's just going to save in a new array list here. When we'll go to add a climb, we will specify a peak name and a time. Notice that this is not a club info object. We'll end up having to make that. Then we see the distinct peak names. Maybe I haven't assigned this one. This all looks pretty new to me. Okay, let's get started. And before we tackle A, we're going to go and make this climb info class. So in IntelliJ, I'm going to make a new project. We're going to go next. I'm going to jump to my 2012 folder. And this is question 1 coming from 2012. Going to expand my project folder, right click on the SRC, make a new Java class. This is climb info. And we're going to jump back to our FRQ. I'm going to copy this stuff. I had some questions about doing this. Firefox tends to let me highlight, copy and paste, that sort of thing. I was having issues with Chrome, and I believe other people were as well. So I recommend Firefox for this. So we're going to kind of format this, but this is just the Java doc for my constructor. And the constructor is complete. Nope, sorry. Implementation not shown. It's not quite the same thing. So what it does, it takes in a peak name and a climb time. In order for this to work, we're going to need some instance variables. So this is a class that they'll be providing for us, and you're just to assume that it works. For our testing purposes, we need to actually finish it out. So we'll create peak name, which is a string, private, string peak name, and we also need a private int climb time. So we're taking in these parameters here. I need to save them into my instance variables, and because I'm using the exact same names, I'm going to use this dot notation, which is outside the subset, but is not quite that hard. So what we have are 2 different variables with the exact same name. Now, in theory, this shouldn't work, but as it turns out, local variables, that is ones that are parts of methods, either as parameters or defined within the body themselves, are different from instance variables. And so we can have instance variables and local variables with the same name, but we need a way to differentiate between the two. If I were just to say peak name is equal to peak name, notice this is grayed out by IntelliJ because it doesn't do anything. I'm trying to take the local variable and save it into the local variable. Cool. I need a way to differentiate because they have the same name, and that's where this dot comes in. This allows me to refer to the instance variable, and so using a right to left kind of orientation, we're saving the local variable into the instance variable. Okay, this is just a getter. So all we're going to do is return peak name. And this is also just a getter. So all we're going to do is return the climb time. And that's going to be it for our climb info. It's just kind of a container object, just holds two pieces of information. Okay. Let's get our main class going here, and that is called Climbing Club. So I'm going to grab all this stuff here. We're going to create the Climbing Club class, and I'll just highlight everything and paste in the starter code that they give me. So we have this instance variable. Okay, I'm going to have to import this, right? On the AP exam itself, you can, on your FRQs, you can assume that everything is already imported. So no need to import, but the list, I'm going to bring in with an import statement. It's not part of the Java default library, that is java.lang. Same thing with array list. I'm just going to hover over it here in IntelliJ, hit Alt-Enter, and import it. So we have our instance variable, we have our constructor, and the constructor doesn't take in any arguments, any parameters. It is just simply initializing our instance variable by setting it equal to a new list, a new array list. Okay, clean this up a little bit. I do like those to be down here. Okay, add climb. To be implemented in part A with climb info objects in the order that they were added. This is kind of different. We see a part A, a part B, and then this is going to be part C. Interesting. This is a little different. Okay, so I have this all brought in. We're going to go back and take a look at what we should be doing with part A by looking directly at the FRQ. Write the implementation of the climbing club method add climb that stores the climb info objects in the order that they were added. This implementation of add climb should create a new climb info object with the given name and time. It appends a reference to that object to the end of the climb list. For example, consider the following code segment. We create a climbing club object. It is there's just an array list inside of this object with nothing in it. When we go to add climb in this order, and then we will go to look at it, they're there in that order. Okay, that seems easy enough. So simply put, we're going to take in a peak name and a climb time, but notice that those things have to be wrapped into a climb info object before they can be added to our array list. So what part A is going to look like, and I'm actually going to leave the comment here, is we're just going to add to our climb list. Right? It's an array list, so we use the add method. And I can't just add peak name, comma, climb time. That doesn't work. Right? This is effectively trying to pass in two bits of information to the add method, a string and an integer, and that's not going to work. What I need to do is wrap those inside an object, and we can actually do it right here at the point where we're going to add it. We can use an anonymous object. That is an object with no actual variable referencing it. I can just create it here. New climb info. Now our climb info, if you recall, it takes two pieces of information, a string, peak name, and an integer climb time. I'm just going to pass along the information that is coming in as arguments. So this will create a new climb info with the peak name, climb time, and then add it to our climb list. And that's it. That's part A. Let's look at part B. Write the implementation of climbing club method add climb that stores the elements of climb list in alphabetical order by name, as determined by the Compareto method of the string class. This implementation of add climb should create a new climb info object with a given name and time, and then insert the object into the appropriate position in climb list. Entries that have the same name will be grouped together and can appear in any order within the group. For example, consider the following code segment. So when we go to add these things, ultimately they need to come out alphabetically. And so instead of just tacking them on at the end, we need to basically loop through what is currently there in our climbing club object, particularly the array list that's within it. And we'll make a comparison using the string Compareto method. Now, that's going to work on this name, that is the name of the peak. And so we're going to have to pull that out of the climbing club object. So, let's get started on that one. So what we're going to do is we need to loop through, and I'll end up testing, but let's go ahead and test this part A to make sure it works. And for me to do that, I'm going to put kind of a dummy return there. Why don't we put it underneath the comment? For me to really test this, I'm going to need a toString to see the contents, the stuff that's stored ultimately in that array list. Interesting green stuff going on here. Okay, so we'll have public string toString. Ultimately, what I really want to know coming out of this climbing club is information about its state. I want to see what is in this array list. So I'm just going to return climb list. Okay, this is mad at me because ultimately I want to return a string. Well, that's easy. I just return climb list dot toString. Right? When it's just climb list, this is an array list or a list. What I want to see is the contents of it. As it turns out, these things already have two strings, and so it neatly formats it, and we can just take a look at that. Let's right click on the SRC. Let's do a new Java class. This is going to be my driver or my tester, and I will plug in a main method with this one. And what we're going to do is recreate this example. Okay? I'm actually going to just copy their code because they very conveniently formatted it correctly this time. And so if I want to see this, I'm just going to do a sout on our hiker club, and that's going to implicitly call the toString. That is hiker club dot toString is being implicitly called. And basically these things just need to get added to the array list within in order. In the same order that our climb info is going to need a toString as well. So why don't we do climb info, we'll do public string toString. And that's just going to spit out basically the name, peak name, along with the time. And why don't we maybe do something like that. Yeah, let's do that. So now when I run this, I'm actually going to get something other than the hash code. We see our first one, and this is telling me that our climb time is not being saved in because I get nothing but zeros. Looks like we forgot to do that. So this dot climb time is equal to climb time. Okay, let's make sure this aligns with what we got here, and that's looking pretty good. Back down to B. I essentially want to do the same thing, except they're going to be in alphabetical order. So as we saw, part A appears to be working. I'm just going to comment it out for now. And let's try out part B. What I need to do is basically loop through the array list, which is called climb list, and kind of look for where the climb info needs to be inserted. Okay. Ultimately, I just need an index. I need to loop through until I find the index where it needs to be, and then I can consider doing that. So I'm actually going to use a while loop here. We're going to create our index ahead of time, and we'll say while. There's two things here. I'm going to be going through using Compareto, and I also need to stay in bounds. The inbounds check is probably a little bit easier to do, right? Because we're working with an array list, we're going to be referring to its size, and I know that I is in bounds as long as it is less than the size. That is climb list.size. Okay, so it needs to be in bounds. But as we're going through, I'm going to be making comparisons. Ultimately, they're going to be in alphabetical order, but they're in alphabetical order based on the peak name. I have it here as a string. I want to compare it to another string. So what I'm going to have to do is pull the current object out and then do a comparison. So we'll say as long as I is in bounds, that I'm safe to pull the object out. What do I mean? Well, we're going to take climb list, which is an array list. I want to pull the current object out, so I'll use get at the current index, which is I. Okay, this is an array list. This is a single climb info object. Ultimately, my comparison has to be between two strings because that's how we're listing them alphabetically, and they tell us to use the Compareto method. So there's actually a getter for that. We will call get name. Okay, this is an array list. This is a climb info object. This is the string. This is the name of the peak name of the climb info. I get all of that out and then compare it to my peak name. Okay. This is the Compareto method. What it's going to do is compare this string to this string. And then we're going to get back either a positive number, a negative number, or 0. If I get a negative number, what it means is that this alphabetically comes before this. If I get a positive number, it means that this alphabetically comes after this. And of course, if I get 0, it means that the two are equal. What I want to know is this comparison, and why don't we bump it down on a new line, if it is less than or equal to 0, what it means is that we kind of need to keep going because this one, the one that is already in the array, is less than the one that I need to insert. So as long as we're in bounds, we can safely pull the current element out. I'm going to get the name of the current element. I'm going to compare it to the one that I'm trying to sort. If I get a negative number, meaning less than or equal to 0, we need to keep going. If I get a positive number, what that means is I can stop there, and that's where I want to insert it. So as long as these two conditions are true, I'm just doing an I++. I'm basically just going through, incrementing my index until I find where we need to go. What it means is that after this loop is done, whatever the value of I is, that's where I need to do an insert. And so we will cleanly insert club list.add at index I. Keep in mind this add method is overloaded. So we can specify an index, where we want to add it, and what we want to add. What we want to add is the climb info object. Just like this. So I think some students may think that we are kind of sorting. What we're really doing is just inserting alphabetically, right? The way that we're creating this thing, we ensure that it is just always in alphabetical order. So let's take a look at their example. And I think they do the exact same thing, but just to make sure, I'm going to copy and paste to make it easy. So I copied that stuff. We're going to come back in here into our driver, and we're going to paste. So it's essentially the same thing. We're just adding climbs, but this time they should be in alphabetical order. And there we go. It told us that same names can be adjacent. That's perfectly fine. These just coincidentally happen to have the higher numbers after that. That does not actually matter. Okay, that was part B. Lastly, we have C. The climbing club method distant peak names is intended to return the number of different names in climb list. For example, after the following code segment has completed execution, the value of the variable num names would be 3. There are 3 unique names. We see that this one and this one are duplicate. Consider the following implementation of method distant peak names. This is a little weird. I don't really do this anymore. They're giving it to us and asking us a question. Okay. So here, if there are, here's the distant peak names. Let's take a look. If there's nothing in our array list, we return 0. That looks pretty good. We create a climb info object, and it is the very first one. All right, we're safe to do this at this point because we know there's at least one element. Why? If there were no elements, we would have already quit. So there's at least one element. We're getting the first one. We have a string that is our previous name, and it is this climb info's object's name. Why don't we how about we do this? I'm going to grab this code. I'm going to throw it in IntelliJ so that we can make like inline comments on it. And ultimately, we can actually test it to know if we're right or not. What I'm going to end up doing is pulling their example and putting it in here so we can kind of use the example to guide our thinking. Okay, let's expand this. And the example in question is this stuff. I think it's the exact same one, but why don't we grab it? And we'll include it as a comment up here. I can just expand this Java doc. Right, we're going to use this as our example. Okay, so let's ask, is the climb list.size equal to 0? No, so we're going to keep going. Climb info, current info, is going to be climb list.get 0. That is going to give us this element right here. So why don't we paste that there? That is our current name. This is our current time. So we're going to do previous name is going to be this object's name. Easy enough. It's that. Current name is null. Okay. And num names is 1. We've essentially already considered the first element, so we're counting that at 1. Because we have considered the first element, we're going to start our index at k. We can basically skip the first element because it's saved already in our current info. But this loop, I'm going to take a quick look at the header, and this looks pretty standard, other than we're skipping the very first one. Our current info is going to be climb list.getk. Well, k has a value of 1. Why don't we keep our k value here? So our current info, which is null at this point, is actually going to be the current climbing info at this point, which if we go back to our example, it's whiteface. Okay, our current name, current info is the one that updated. So it is changed. And then our current name is going to be the current info, which we just updated, but the name of that. So it is whiteface. Now, let's compare previous name. Well, previous name is this to current name and see if it is not equal to 0. This is basically They're using the Compareto method like it's an equals method, and that's perfectly fine. But if we get something other than 0, that means they're not equal. So we're asking, are these two strings the same? They are not. So we would enter the body of this if statement, and our number of names would increment by 1, so it will go to 2. And then our previous name, which is this one, would become our current name. So we'll update it, and it is now whiteface. That's the end of the iteration. We'd come up, we'd increment k. K is now 2. We would then say, is 2 less than our size? That is true. Okay, so we'll take climb_list.getK. Well, k is currently at index 2. That's going to be this one right here. So let's pull that. So I just updated my current info. We're going to pull the name out and store that into current name. We'll then compare previous name, which is whiteface, to current name, which is this one, and ask, are they not the same? Well, they're not the same. So we'll increment our number of names to 3. We would then say our previous name is now our current name. That's the end of the iteration. We'd come back up. We would increment k. We would ask, is k less than our size? Our size is 4, so yes. We would grab the third element from our climb list, which is this one. We would then pull the name out of that. And then we would make a comparison. We would ask, is previous name compared to our current name not equal to 0? Well, they're different, so that would be true. We would adjust this. We would then update our previous name. That's the end of the iteration. We'd come back up, adjust k. We would ask, is 4 less than 4? It is not, so that is the end of all this. We would return num names, which currently has a value of 4. Now, they gave us this code, and instead they're asking questions, which I don't know if I've ever seen this. Assume that add climb works as specified, regardless of what you wrote in parts A and B. Does this implementation of the distant peak names method work as intended when the add climb method stores climb info objects in the order that they were added as described in part A? Basically, if we ran it through like this, we would get the correct number. Now, keep in mind with this example, we were supposed to get 3. And ultimately what we would get back is 4. Let's show that. So I'm going to flip over to my driver. And, sorry, not yet. I'm going to bring back part A. Right now, I have the part B implementation. Let's comment back in the part A implementation. So what that means is that these climbs, they get added in the order that you try to add them. So based on that, if we were to print off our hikerclub.distinct peak names, I think I said distant several times, I'm supposed to get 3 because there's 3 unique ones, and instead we get 4, just like we saw whenever we traced it. Now, the next question in C is, what if we did the other implementation? What if we have part B's implementation where they are alphabetical? You want to try that? Well, I'm going to comment out part A. Let's bring in part B. I'm going to actually just go ahead and test it, and then we'll maybe consider tracing the code. Notice that we get 3. So we actually already know our answers here. It's no for this one, yes for this one. But let's figure out why it ends up working when they're in alphabetical order. Okay? So when they're in alphabetical order, what it means is that even though we add them in this order, the way they exist in the array list is slightly different. They will be in alphabetical order within the array list. So why don't I just quickly shuffle this to alphabetical order. You know, if we make, maybe an index can help you if you're a little bit lost. So I'm going to do indices here. Really, I don't even need the add calls. It's just the climb info stuff that's important. How's that? right? Index 0 should be this one, this is 1, this is 2, this is 3. We see this whenever we go to print it off, and they're in that order using the implementation for B. Okay, so let's assume it's in this order, and let's run through the code again. We would ask, is our climb size equal to 0? It's not. It's equal to 4. There are 4 elements in there. Okay, let's pull out the first element. We know there's at least one element because we've already verified that there's not none. So this is the first element. We would then set our previous name to this element's name. Current name is null, and this is going to be initialized to 1. We've effectively already considered the first element, so our loop is going to start at index 1, which means k is at 1. We're going to pull out the current element from our climb list. Okay, well, since we're at an index of 1, that's this bad boy right here. So that is the value of current info. We're going to take that object that we just set on the previous line and pull out just the name. Okay, we're then going to ask, is previous name, well, previous name currently has this value, compared to current name currently has this value, are they the same? Actually, this is asking, are they different? In this case, they are different. So we're going to increment num names. Num names is now 2. We're going to update our previous name by saving in our current name. Our current name is this, so we'll use that to override our previous name. This is what's currently our previous name, and so we would end up with this as our value. That's the end of the iteration. We'd come back up, adjust k. We would then ask, is k less than 4? It is. We would pull out the element from index k. Well, the element currently at index k, 2, is this guy. So that's our climb info now. We'll pull out the name already there. We're going to ask, is previous name compared to our current name not equal to 0? In this case, they're the exact same. So we would get back 0. We would ask, is 0 not equal to 0? We'd get a false. We would skip over this if statement. That's the end of the iteration. We'd come back up and increment k. So notice that when I have back-to-back names that are the same, we're perfectly fine. We would ask, is 3 less than 4? It is. We're going to then get the element at index 3. That's this one. We're going to save that into our current info. We're then going to pull the name out. We would then ask, is previous name, that's this, compared to current name, not equal to 0? Are they different? They are. So we'll increment num names to 3. We would then update our previous name. It is now this one. That's the end of the iteration. We would increment k. We would ask, is 4 less than 4? It is not. So we're done with our loop. And ultimately, we'll return the final value of num names, which is 3. So we're okay as long as they're in alphabetical order. So using, the answer here is no. The answer here is yes. We'll wrap it up there.